This video is about design patterns, and we're going to use them in App 05, the rock, paper, scissor game. So design patterns, there are whole books on design patterns. We're only going to use one. As you can see, they come in groups, creational patterns and structural patterns, and they're used to solve commonly occurring problems in software design. The design pattern we're going to use is MVC, which came from Java. It was built into Java, commonly used in Java, but it's also a design pattern that's used in ASP.NET and C#. So it's a very common pattern, and the idea is to separate the user interface from the model and the controller. So it's got three parts to it. So the user sees views and uses the controller to manipulate the model, which then updates the view. We won't have three classes to implement this. We will have a model of the game, and we'll have a view controller for the game, the user interface. So the game itself is a well-known game, usually played with using your hands, and you can play it for as many rounds as you like and just count the number of rounds that you win. So as you know, there are three choices, three hand shapes: the shape of a rock, the shape of scissors, and the shape of paper. So in terms of features, we want the user to be able to start a game and ask for so many rounds to make up the game. The player should be able to select rock, paper or scissors, and the computer will then select one of the choices at random, and the computer will then score who won that round, and so on. And finally the computer will decide who the final winner is. So those are our five straightforward features. So I'd like you to create a use case diagram similar to this one to show the player and the computer, because they're both users in this use case diagram. So the player can start the game and set how many rounds there are. They can select their choice, and the computer makes a random choice and scores the round and shows the winner when the game ends. So as I say, we're going to have two classes. We're going to have the game class, which is the model, and a view controller class, which is the user interface. We can use an enumeration because there are two users of the game, the computer and the player, and we can also have an enumeration of choices in the game: rock, paper or scissors. So if we look at the model of the game, we need to think about what information do we need to keep track of as the game changes and progresses. What state is the game in? And we also need attributes for the player. So the player will have a name, will have a score, and the player will make a choice. The player's name won't change during the game, so it can just have a get method but not a set method. But the score is going to change during the game, and also we need to be able to set the player choice as well as get the player choice. And then we've got attributes for the computer. We've got to keep the computer's score and the computer's choice. We also have properties for the game. How many rounds are we playing? What's the last round going to be? What current round are we on? Who is currently playing? And who the winner eventually will be. So what are the view controller methods? Well, they're going to deal with the input and output with the real player. So i.e. asking the player for their name and how many rounds they want to play, getting the player's choice. Also they need to show the computer's choice and the score for that round, and finally show the winner and the final scores. So our game design can be summarized like this. We've got a game view, or a game user interface, and a game model. And we've got two enumerations. So typically for games, you have a start and an end. The game starts somewhere and ends somewhere. And during play, we need to keep track of the score and also what choice the computer is making. So we can see in the user interface, the user will ask for the game to start, and that'll be passed on to the game, which has a start method. And so there's our view. Now, one of the key things about this whole design, which you must stick to, is the game class is the logical model of the game. It knows nothing about user input or user output. That's handled by the view solely. And the reason for that is APO 6 is going to be a second version of this rock, paper, scissor game. It will use the game class again, but it'll have a different view. It'll have a graphics user interface view. And if you've programmed it correctly, you won't need to alter the game class at all. We can use it directly in and replace the game view with a game graphics user interface instead. Okay, so we are also going to have unit testing for the game. Okay, so let's make a start on the coding. So we'll start with our enumerations. So in APO 5, I'm adding a class. This is going to be game choices. It is an enumeration. Okay, so it's nice and simple, rock, paper and scissors. We don't need any usings. And we'll save that. Now let's add the game players. Again, we don't need any usings. And finally we're going to add the game itself. So I'm going to start with attributes, which are definitely attributes of the game, and in particular the round, which round the game is in. And I think we should set a maximum. So I'm going to set a maximum first. Doesn't matter what you set as the maximum, but let's say it's 10. But then we need to know which round are we in. Because we're using test-driven development, we're going to use public properties. Now in my slide, I had a player name, a player score and a player choice. Now thinking about this, that should be factored out as a player. So I'm going to add a player class now. Okay, so I've created this player who has a name, which we can get but not change, because it wouldn't change during the game. The score will change during the game. Again, the player type, which is either computer or a real human being, that's not going to change during the game, but the choice will change during the game. So those are the attributes of a player. And we can now add to the game 2 players. And finally, we need to know who is the current player, whose turn is it to go. That'll change every round. And who the winner is. We can now think about a constructor for the game. And the first thing we'll need is the name of the player. So that we can create a player. So let's create the human player. That immediately brings to mind, has the player got a constructor? No, it hasn't. So what do we need to initialize a player? Well, we need the name. We don't need their choice yet. We do need their type, don't we? Now you can't use the word type because that's a key word in other languages, so I won't use the word type. I'll have to say player type. So if we know their name and whether they're human or computer, we don't need to know their score yet, and we don't need their choice yet. And the choice, can we set the choice to? Right, we haven't got a non, have we? Okay, so like I did with the players, I had a non. I think if we don't know what their choice is yet, we should have a non for game choices so that we can initialize that to non to start with. Okay, let's just check. Go back to the game. Okay, so the player needs a name. And a type. This is the human player, and we need a computer player as well. Okay, so we've initialized the two players. We haven't initialized the round yet, have we? And the current player, I think it's only fair to let the human player start. So actually don't need to do that yet, do we? Because what we need is a start method, don't we? Now this should be a method which could be used at the start of the first game, but also if we wanted to restart. So if we're starting, the round is definitely 1. And I think the current player should always be the human player. So that the human player has that advantage of being always to start. Right, what's happened with current player? I've made the current player a player. So I've just got to say sorry. And the current player is human. So are you ready to start the game? We're on round 1. We don't know the scores, do we? So the human score would be 0. The computer score would be 0. I think we're ready now, aren't we? I think we're ready to start. That should build without any errors. This is a good point in which to save our changes, because we've created the game class and we're started playing the game. Okay, so now we're going to start testing it. So we're going to go to our console app tests and add a new test class. And what we need is to hook in the unit testing framework from Microsoft and annotate the class. We want Apo 5 this time. We're then going to add our first test method. So I've created a private game here which all the test methods can use, and we're ready for our first test method. So this first test method is to test the starting of the game. And we're going to call the game start in a minute, and then assert that the player score is 0, computer score is 0, we're in round 1, that the current player is the human player, and that the game, the player name, isn't null. Those are the asserts we're going for. Okay, so that's similar to what's in the slide, but we've changed things by having a player class, so it's game.human.name, and I've checked for the actual names this time. So let's see if those tests work. So they don't. Something fails. It looks like it's the expected name. Oh, right, yeah, okay. So although we created a new game with the name Tim, and we've checked for Tim, we've actually got Gita. How did that happen? Well, that happened because I made the mistake here, which you didn't spot. So see how easy it is to do? The game is passed a name, and that's the name that should be used. So that each time the game starts, it can start with any name, not just Gita. So there's the mistake. If we run the test again, it does now pass, and we've tested setting up the game to start playing. The next thing we're going to test is that the computer can make a random choice between rock, paper and scissors. And it's rather difficult to test that, because every time we ask the computer to make a choice, it may make a different choice. What we want to know is, on average, will rock be chosen 33% of the time, paper 33%, and scissors 33% of the time. So we're going to use a random number generator, and we're going to have a method called getComputerChoice, and we're going to assert whether or not in say 1,000 choices we get at least 300 choices for each of the 3. So here's how we're going to set the test up. I'm going to create a new game. I'm going to start an array of integers, which are the choices, and create an array with only 3 elements in it. I'm going to go around 1,000 times asking the game to get the computer choice, and then because that choice will be rock, paper or scissors, we'll convert that into an integer and use that as the index to the array and increase that element in the array by 1. And then we're going to assert that they should have at least 300 of choices of the 3 different choices. So we'll do test-driven development approach this time. We'll write the test first, and then we'll write the code to get the test to pass. So I've got this far at typing the method in, and inside this loop I'm going to have to call on the getComputerChoice, but that doesn't exist yet. So I need to go to the game and add it. I'm going to change its name because get suggests that this method will return a value. When it doesn't return a value, it simply stores the choice inside the game. So I'm going to call it makeComputerChoice. Okay, and there's no code there yet. Okay, so I've written the rest of the method now. I think I've made mistakes, but let's just see what happens. So it has failed, and the assert has failed, doesn't give us any detail about why it's failed. So let's do a bit of debugging then. Let's go to there. Let's see what we can find. If we do a test, debug all tests. Okay, so how many choices 0 are there? Okay, we can see down here, I don't know why we can't see it by hovering over choices. Oh, there it is. Yes, so there were 10,000 of choice 0 and none of choice 1 and 2, which is hardly surprising because we didn't make any choices. So that was the result I'm expecting. So let's move on and write the code now. I think I'll leave the breakpoint. So we're going to make the choices now. Okay, so we now have a make computer choice method using a random number generator, and it sets the computer's choice depending on whether the choice is 1, 2 or 3. So if we go back to the test, let's run the test again, or debug the test again, because I am expecting problems. Okay, so what choices have we got this time? Well, we have no choice 0. We got 5,000, roughly 5,000 choices 1 and 5,000 choices 2. So why have we got no choices with 0 in? Well, the answer is that our choices don't start at 0. They start, first choice is none. So we're really considering choices 2, 3 and 4. So I'm going to increase this array to 4 elements. And I'm going to change this. So we are expecting choice 0. So I'm expecting choice 0. There'll be no choices 0 because choice 0 is no, is none, is not paper, it's not rock, it's not scissors. So we're expecting 0 of those. So we are expecting a 4th choice here. So that's what we're expecting. And if we debug that again, what we find is that we have 0 for choice 0, which is fine, but we've got 5,000 choice 1, 5,000 choice 2, and no choices 3. And that's because it's the random generator is a bit odd. I put 3 in there. If we just show what that represents, that is, there are 3 variations on this next method. That is, an integer is a maximum value, but the problem is it returns integers which are always less than that value. Okay, so what I'm going to do is I'm going to change this so that is 1 and the maximum value is 4. Let's try that. There we go. Now we have no choice for 0, and we have roughly 3,300 choices for the other 3 choices. So I'm happy with that. Test has now passed. We can't test the player making a choice because that's going to be in the user interface. But what we can move on to test is whether the game can update the score correctly. So we can set choices and expect the score to be increased. So we're going to have a simple scoring system. If you win a round, you get 2 points. If it's a draw, you get 1 point each. If you lose, you get 0 points. So we can check all those. So here's the code for scoring a round. We're just going to check that if its player has rock and the computer has paper, then the computer score will be increased by 2, and the winner of that round is the computer. And there are 6 possibilities to check that way. I won't do them all. I'll just do 1, I think. You can do the other 5 yourselves. So let's add another method to the game. I won't put any code in it yet. Let's get the test in place first. Okay, so I've entered the test where the human's going to choose rock and the computer's going to choose paper. The computer should win, get a score of 2, the human should be 0, and the winner should be computer. Obviously there's no code exists for scoring the round, so if we test this, it's going to fail. Yep, it has. So let's now write the code in the game for scoring the round. Okay, so there's the code for checking. Human chooses rock, computer chooses paper. There are 5 other combinations that need to be added. I'll leave that for you to do. And then you can check the round. If it's less than the last round, you can increase it by 1, else you go to the game.end method, which hasn't been written yet. I have just added a last round in there, but it needs to be set by the view controller what the last round actually is. But we haven't done any user interface yet. We are simply getting the model, the game model working. Let's try the test. And there we have, we've passed. Ending the game is relatively simple. We're simply going to check the different scores. So we can just set the winner based on whether the one score is greater than the other score or less than the other score. If they're equal, there is no winner. Okay, so now we've completed the model. We now can start thinking about the game view. So let's save the changes at that point. And let's move on to the game view, which we don't have yet. So we're going to add a game view. So I've added a game view, and the game view obviously needs a game. And I'm then going to add a method to start the game. So last time I did it, I used some of the console methods to try to get more control over how it looks. So I decided I wanted a yellow background and black foreground, and I can also change the size of the window as well. And then we're going to output a heading, and then we're going to ask for their name, providing the game is null, because remember this start game might be called more than once. So if they've already started a game, finished a game, and then they come back here for a second time, they won't want to put their name in a second time. They'll want to just go straight and start the game. However, I've done something which breaks one of the principles. Which principle is that? Well, it's the single responsibility principle. That was 2 things in one method. Setting up the console ready for the game and starting the game itself are 2 different things. So I'm going to split those into 2 different methods. Okay, so I've put those 2 methods in. The start game method calls the setup console method, creates a game if the game doesn't exist, asks for the player's name, and starts. Now is the first time we can try to run it by going to our program class and hooking it in. So I first of all got to put a private static GameView and I can't find GameView because I haven't included the project folder yet. So you must include using Console App 5 folder first, then it should find the GameView. Yep, it has found the GameView, which I could call App 05, yep. But that needs to be a new GameView. So App 05 is a GameView, and we can call for the moment, we'll call the start game method, although that's not necessarily the best way of doing it. App 04 had a display menu, and so did the grades one. Okay, but hopefully now we have got 5 choices. Yes, it's in the choices list, so hopefully we can get to it now. So if I go to 5, yes, there we go. I do need to change the foreground colour. I thought perhaps the foreground colour would be black by default, but it isn't, so that needs changing. So let's try that. Understand why it hasn't come out in black. I think it's because I decided earlier to use a foreground colour of yellow. I'm going to swap these around. You can play around with this if you want, but let me go back to something I know works. There we go. We've seen some of the user interface side of things in Start Game. What we haven't seen is the controller side of this GameView class. So going straight to starting a game is not the best strategy, because essentially a game is a repetition of playing rounds. So I've added a play method, and this play method is going to have a loop in it, and it's going to go around this loop until they want to quit. So to start with, they won't want to quit. So there's our main loop. And obviously the first thing we do is start a game, and the next thing we do is we need to get the user's choice. Then we need to get the computer's choice. Well, that already exists in the game. Then we need to score it. And then we need to check if the game is over. And put some output out. And put some message out here. So obviously this method doesn't exist yet. So that will get the player's choice and display it. But here the computer makes a choice, but we haven't displayed it, so we do need because we'll need a display player choice as well, let's call this display choice. And we'll have a parameter which passes the choice. It's in the game, isn't it? Game.computer.choice. And we could therefore do this. We could just have get the player choice, and then we'll call display computer choice. Display choice. and this would be game.human.choice. So when we get to the last round, we do need to write out who's won and what the score is, but we also need to work out whether they want to quit or not. So we'll have to ask that question as well. So that might be worth putting that in a separate method. Okay, I'll just show you one more thing because I want to leave you plenty of things still to do. We do have an extra class called GameImages. And if you look at these use the console to move the cursor to a particular position on the screen so they can draw out the shape of scissors. So we have a draw scissor method which can be put at any particular position on the screen. We also have a draw rock method, a draw paper method, a draw smile if you won the game. Don't know why we want a smile and a thumbs up, but anyway, we've got a thumbs up and a thumb down. So you've got some images you can use, or some images drawn out on the console. So let me just show you one of those, and I'll leave you to finish it. Right, in terms of testing, I'm going to make that true. So it will only do one round to start with. So it'll do that and then quit. Because I want to be able to test all these methods. I don't want to have to go around every round to the last round before I finish. And here, display choice is where, just for now, I'm going to set a choice. And instead of calling the start game method, we'll call the play method now. I might make the start game method private. Let's try that. Actually, I shouldn't have done that because no choices have been made yet. So here, let's just force a choice. Game choices. What I should have done was this. That should be game choices.scissors, and then I don't need to set it here. And I can just do that. Try again. Oh yes, of course, now we get to these not implemented, so I'll take those out. There we go. We've got some scissors. Okay, I'm going to leave the code there for you to finish. So let me reiterate what's left to do. So these are the 8 features the game should have when it's complete. And then you must complete the unit testing, complete the black box testing, complete the GameView class, and complete the wiki page.